In this lesson, we're going to investigate oxidation numbers. Our lesson objective: determine the oxidation number of atoms in a chemical reaction. Some chemical reactions are classified as redox reactions. And in redox reactions, electrons are transferred from one species to another. And this can give us a multitude of outcomes, such as why things rust, why apples turn brown, how we get electricity from batteries, or even why the Statue of Liberty is no longer this color. And so to follow that transfer or that flow of electrons, we assign what's called an oxidation number or oxidation state. And that's listed in the upper right-hand corner of the element boxes on the periodic table. These should look familiar because these are going to be equal to the charge we had in the previous lesson for our ionic compounds. And so there's some rules for assigning these oxidation numbers for our species. So first rule is that uncombined elements, meaning that they're not in a compound like calcium here, have an oxidation number of 0. This also includes any of the diatomic elements. Remember, we have 7 of them, like chlorine, because it's also not in a compound. And so we assign our oxidation numbers by putting them in the upper right-hand corner above the symbol. The second rule is that elements and compounds have the oxidation number listed on the periodic table. And recall, for nonmetals, we're going to use the negative oxidation number, just like we did with our charges in our previous lesson. So group 1 is going to have +1 oxidation numbers as listed in the upper right-hand corner. Group 2 is going to have +2 oxidation numbers. And then group 17, since those are nonmetals, going to have the top number, which is the negative. So for chlorine, it's going to be -1. The third rule is that in ionic compounds, the metal, that's the positive cation, is written first in our chemical formula, and then the nonmetal, the negative anion, is going to be written last. So if chlorine is written last, we know it's a nonmetal, we know it has to form a negative charge, and we know it's going to have a negative oxidation number. And so we look up chlorine, we see it's a -1, we could assign that. And then for sodium, that's written first, that's our metal, that's going to be a positive +1, and we write +1. And notice that +1 -1, that the overall charge of our compound is still equal to 0, like in our previous lesson. So that brings us to rule number 4, which is that the sum of the oxidation numbers in a compound must equal 0. And so if we look here for calcium chloride, CaCl2, chlorines are negative, so that's going to be a -1. Calcium from group 2 is a +2. But don't forget that we have 2 chlorines involved here. Right, so each one's -1, but if there's 2 of them, 2 times -1 gives me -2. And then for the calcium, we have one of those, that's a +2, and so +2 -2, the sum of the compound equals 0 and is neutral. Another way you can do it is you can just say, if I know this is -1 and there's 2 of these, -1 times 2 is -2, +2 equals 0. So always make sure that the compounds have a total or sum of 0 for the oxidation numbers. So let's check your understanding. Can you determine the oxidation number of atoms in a chemical reaction? At this point, you should be able to determine the oxidation number of atoms in a chemical reaction.